Hello everyone, and Merry Christmas. In the Science Department, we're really sorry that this year we can't bring you the regular live Christmas science lecture. So instead, I've been talking to some colleagues and friends and reminiscing about Christmas lectures gone by, looking at some old videos and footage, and I've collated it all together, and hopefully you'll enjoy watching the following video. Paddy, Mr. Stephen, you've been involved in the Christmas lectures since 1987. And he was involved in the.
It was 86 going to 87, and it was Ian Lancaster was the then interim head of chemistry, and he decided to follow the Royal Society lectures and organise a science lecture called The Origins. We basically did it around the origins of life on Earth. I did some stuff on obviously on Darwin, and the physicists and the chemists did the stuff on basically the primeval soup. There was an awful lot of sulphur around, if I remember rightly, probably too much for any health and safety executive now, but there was a lot of sulphur going on, and we basically looked at the origin of life. It was opened up, the Science Society put the lecture on as something we would do on the Tuesday afternoon of the end of term, and anybody could come. Lots of sixth form scientists used to come along, lots of staff. The music department were really keen on it. They really did enjoy that, and they would come along. And so it was staff, it was pupils, and people turned up. And it was great fun, and it was entirely voluntary. But it was down the idea, as I said, the Royal Society lectures. So the point was to try and make science entertaining, fun, but actually informative.
I want to show you now what can go wrong if you're having a barbecue and you're having difficulty in lighting the coals on the barbecue, or you think they're going out, and you think, well, I'll just spruce it up a little bit, I'll throw a little bit of fuel on it. Well, this is the fuel end, and I want you to imagine that the barbecue is going on at this end, and here's my light to represent that. And either you attempt to throw some fuel on it, or you leave the top of your fuel source open. Now, my fuel is just going to be some ether, and I think after a while you'll probably smell it, and I don't want to put too much on. But what I am hoping, if we wait, it depends upon the temperature of the room as to what happens, but I'm hoping that within a few seconds, not yet, you might just see what happens. And that would be you if you were next to the fuel source. Thank you very much.
Yeah, look at the main film now, please. Wait a minute, Mark, wait a minute. Go on then. Excellent. Woo!
thinking about things that cool down food so that we can enjoy it, like ice cream, or preserve it, like perhaps in our freezers. And the aim is to cool something down very, very quickly. So the next time you look at a beef burger that's been in the freezer or something like that, it's cooled down very quickly. The advantage is that during that freezing process, bacteria can't grow.
P is for enzyme music. Now I set Trevor out to take us to a challenge of trying to make an enzyme sing for us. And then I feed for my daughter a little musical called an ocarina. That doesn't work for everybody. Is it on there?
Yep.
So what I want to do is try and use an enzyme to generate some music for us. And the enzyme I'm going to use is something called catalase. Now catalase is abundant in lots of animal tissue, particularly liver. And inside my bottles here I have some ground up liver, and catalase is about the most abundant in liver in your body. And what it works on is a molecule called hydrogen peroxide. I won't worry too much about the chemistry. Hydrogen peroxide is a waste molecule your cells produce, and it's a toxin. So your catalase breaks down hydrogen peroxide to harmful things, water and oxygen, and in the process produces a gas, of course, which I'm hoping is going to drive my ocarina. So there you are, there's our option. So what I need to do, I've got my enzyme in there. I have to add some hydrogen peroxide. I normally do this in a test tube, but we're of course going to do a lemonade bottle. So here we go. It goes to hydrogen peroxide, and you'll be able to see that it fizzes quite dramatically as the oxygen comes off. And if I'm at all skillful, here. It feels quite warm, then it comes out. And hopefully, there we have a music enzyme.
Somebody peeled over.
It fell.
It's the shop. Okay, grasshoppers. There's lots of grasshoppers. Look down here. Why is it that we won't eat them? They're just the same. They're the squid, mollusk, mussels, mollusks. We eat those. Arthropods, we'll eat. Probably lobster's the most expensive food you can buy. All it is a crustacean, same as we've just been eating now. So who is prepared to take the challenge? We have in front of us.
Whoa, what is it?
Some interesting food. Right, so fancy a Thai green curry cricket? That's disgusting. That's really nice, that. Right, okay. They get worse. The next one is a nice little, it's called a grub. Here it is. See that these. It works. They're dry. Now then, the next ones. Do you want to go next one? Next one. Yeah. These are bamboo worms. Oh, I don't like them. Bamboo worms. So do you fancy one?
Are they alive?
Yeah. And then we have my special favourite. Medicinal, bit of white wine. Round it tomorrow. Now, we've got the last one, and this is the roasted scorpion. Now, it's a bit crushed up here, but what we're going to do is we're going to go for the claws. Because they're the bits that look most repulsive. So, do you focus This is roasted scorpion. Okay, so there we go. Not sharp, mate. Right. I think we ought to give Jazz.
Three, two, one, go. going to walk around here and then we'll all walk on and I'll go 3, 2, 1, go.
I thought Mr. Announce when I press space.
Yeah, on go, press space.
3, 2, 1,
So go.
go.
Rather than
Yeah.
And like everyone puts it in on go.
As soon as you put it
Is it go or
Sorry,
go?
Go.
Yeah, go.
Right, so I press space bar and go.
Yeah.
When the solutions go in.
Just make sure it's in
When the solutions go in.
Yeah, which is on go.
Which is on go, right.
And you count down 3, 2, 1, go.
Okay.
Now back, space,
Okay.
you two. Get a room.
Way.
That's basically the Fred Galilean relativity. Illustrated here with an old style railway truck and an apple. The girl sees the apple fall straight down. The guy going down the railway truck sees it travelling at parabola, okay? That's Galilean relativity. Now to try and demonstrate this, I don't know if you know, but I'm actually quite a good juggler. Okay, so there we go. I know how difficult it is to learn a new juggling trick, okay? Because it's all about overriding your instincts. You know where the balls are going to be, your hand automatically goes there. To override that is very difficult. So, a very good test with Galilean relativity is if I can juggle whilst moving at constant speed, okay? The physics on this skateboard are at all different to the physics when I'm stationary. I'm not going to be able to do this, okay? Okay, so I'll just mention briefly, I'll show you all here about Einstein. We call blue bottle, and basically you can see that it's colourless to begin with, and then if Mr. Lancaster gives it a good shake, and then if we leave that, it will go colourless, because what is happening as he shook the bottle, he added oxygen, it was oxidising the indicator and going blue. And then, as the reaction is left, the glucose and the sodium hydroxide, in the absence of the oxygen, takes it back to the blue colour. And that will go colourless in a minute, and we can go between the colourless and the blue. The next one, if Mr. Beckhoff just would help me a minute, is one in which I am going to mix these two chemicals and set the stop clock going. I'm going to see how long this one takes, and then repeat it with one other one. Now this is an experiment which produces iodine. Are you ready? 1, 2, 3, go. Give it a stir. And what's happening here is the reaction is producing iodine, but there's some sodium thiosulfate in there. And as quickly as the iodine is being made, the sodium thiosulfate is getting rid of the iodine. But there comes a time when the sodium thiosulfate runs out,
and the iodine has got nothing further to react with except with a starch that is in there, and so with a bit of luck we will see a reaction occur as soon as the sodium thiosulfate has run out. And when we did it the other day, it was about 58 seconds. It will vary according to the temperature in the room. Keep our fingers crossed. Keep our fingers crossed. Our fingers crossed. There you go. It in 61 seconds. With a bit of luck, this should do it. You ready? Well, I don't know. I'm going for 30 seconds. This one's got colours. Give it a shake again. Should lose its colour. How are we doing? Getting close. Getting close. Getting close. No. Now, if we've got quantities right with this one, where one goes into the other, not a great deal should happen. But when this one goes into this one, two things might happen. Finally, 6 beakers, pouring in some sodium hydroxide, beakers half full, not a great deal happening. With a bit of luck, we go back and fill it up, we get our Christmas lecture for this year. We hope you've enjoyed it. We hope.
Remember why I'm doing this again?
Because you're the only one daft enough to do it.
Hello, Christmas lecture. How are we? Yes, as I said, the live version of me said this is too dangerous to perform live, so therefore we're doing it in a fume cupboard so nobody dies. Good times. Right, if you want to bring the camera in, let's have a look at it. So what we're reacting is magnesium and silver sand. In the silver sand is the silicon. And the first part of this is heating the two up to react together to then dump it into hydrochloric acid to then extract the silicon from it. And what we should be left with, a little Blue Peter special, is this. This is pure silicon. Okay, looks not particularly nice, but there it is. Right. So, first of all what we do is we heat up the magnesium and the silver sand. Now what's going to happen is this is going to heat up and glow and it's going to turn pretty black as well, and we've got to chase the reaction with the Bunsen burner. Okay, so it should go in a spectacular style any minute soon. Right, see it's glowing, 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 glowing. All of a sudden it should go. And there you go, starting to go. So when the tube turns black is when it's hot enough and reacts. Now you might hear the occasional pop. The occasional pop comes from the water vapour that's present in the tube, produces hydrogen gas as it reacts, and that's the hydrogen gas that's then popping off. So I'll just react this last little bit. There we go. Perfect. Right, so what we've got now is we've got our products, which is magnesium silicide. The magnesium silicide we're then going to drop into hydrochloric acid, and what will happen is quite a violent reaction. Once again, this is another part that we're not allowed to show live. That violent reaction will leave a precipitate behind, and that precipitate is our silicon. However, what comes off the top are quite explosive little bangs, as we're about to see in 3, 2, 1. So what you've got there are silanes. Now the silanes are the things that are toxic, that we can't breathe in. Now silanes are extremely reactive with air. So as the gas comes up and off, it reacts with the air, and you can see the tiny little explosions all kicking around somewhere in there. So we wait until the pops disappear. It's a bit like making popcorn. Wait till the pops stop. As you can see at the bottom there, you can see the precipitate starting to form. There's your silicon. Right, so you can see it's finished reacting now. Okay, the pops have more or less disappeared, so what we're going to do is we're going to filter it. Now, the wondrous thing about this is, as I tip this into here to filter it out...
We're looking at a picture of Mr. Shred in the lecture theatre from years ago. So this was a picture of 1999 where, and I didn't notice, but sitting next to Mr. Shred
is Mr. Shred.
Is Mr. Shred.
Yeah. So some of you will know Mr. Shred on the very left, who's a very young boy. So that silly string that he's getting very excited about.
I think they were party poppers. I think
party poppers, yeah.
Party poppers
can't remember what that was in aid of. And then a very young looking Mr. Old Shred in the yellow shirt, obviously having fun with his son there. So there's some other people, previous geography teachers sitting behind Mr. Shred, Miss Lowther, and a previous music teacher, Mr. Pemberton, I think, sitting behind Mr. Shred. Yeah, so some people we remember from a long time ago in that photo. So that was in the lecture theatre back then. We used to just cram everybody in on, I think it was the last Tuesday of term after school, and it's grown quite a lot since then.
What are your favourite demonstrations that you can remember?
Well, I think, yeah, going back to because I do loads of music, so I enjoy those the most. And I think I can't remember what the actual lecture was about now, but we decided it would be great to do the 1812 overture to science. So obviously the cannons were some hydrogen and oxygen balloons going pop, but we decided what a good idea it would be to have the Rubens tube going on at the same time, and I can't remember what else was going on, but there was all sorts of whizzes, bangs and pops going on at the end. It was a really good idea until we sat down and decided to do the risk assessment, and suddenly realised that it was quite complicated. We had to think that through really carefully to make sure everything was safe. Yeah.
So I mean, from physics, we looked after the Rubens tube.
Yes.
And from a safety perspective, if you just describe the Rubens tube and why it's slightly dangerous.
Okay, so the Rubens tube uses propane gas, and you have to flood. It's basically a big hollow tube with lots of holes in the top, and you flood it with propane gas, and you light the gas, so there's lots of flames coming out of the top, and the idea is that you play sounds down it, and the longitudinal standing waves, if you do A-level physics, set up lots of pressure variation along the tube. So some flames are higher than others where there's higher pressure, And the idea is when the sound changes, the flames dance about, and it's quite fun, which is great. Apart from you have propane gas potentially going onto the floor of the hall, and then you've got naked flame and hydrogen in balloons fairly close by, so which you keep safe because you have a very long splint at the end of the meter, which is great if you've not got a Rubens tube also to worry about. So yeah, we had to put talking about things that went a bit wrong, and the crazy, like all the food and the crazy things that we got in. So corn flour was something that we did. So we just made lots and lots of thick corn flour paste. Yeah, the custard thing. So that's when normally it works really well. So you make really thick corn flour and you put it in a tray. And you get somebody with a mallet, to hit it, and it's a non-Newtonian fluid, so if you hit it really fast, it's like a solid. What I hadn't realised was that if you leave it to settle over a few days, there's a nice sort of liquid layer on the top. And one of the pupils came along, and I said, "That's all right, you don't need like a lab coat or anything. This is live," and he hit it with a mallet, and it just absolutely went everywhere. So we learned quite a bit on that day. And the crazy things. I mean, you're getting all that food in. What else have we got in? I think
liquid nitrogen.
Yeah,
a couple of times.
Yeah, liquid nitrogen. We've got some inflatable turkeys, and Mr. Robinson, there was a forum of the lab techs of the craziest things you've ever been asked to buy, and that featured quite highly in inflatable turkeys. What else have we? Self-driving car. I don't know whether
I've
you
got
got
video.
that.
I've got video of
Charlie Barry.
Charlie Barry.
Driving it.
With no hands, driving reverse parking this a Volvo, white Volvo, back of the manhole. So that was all to do with perception things in cars.
Yes.
How
you did the expedition that was great. Charlie Barry was that.
I liked my when I did circumcision and trepanation.
Oh yes.
They went down my thighs. How many did I do?
Yes.
Oh yeah.
We had some people who were applying for medicine. Went down, didn't we? Yeah.
That was good fun.
Was that something to do with the skin grafts, wasn't it, as well?
Yeah, and it was the guinea pig club. Yeah. I really enjoyed that one. It was just really interesting.
Yeah, we
medicine through the ages.
Yeah,
that was
I
was doing medieval. No. Yeah, it was just medicine through the ages.
Yeah, and then we ended up with Aptimus and nanotechnology.
And I did the ancient Greeks. I did the Heron's Fountain. There's another one talking about what's it when you siphoning? Yeah, so talking about siphoning. And I had a model wooden train going over a hill. Yes. And it all fell to pieces and I started to push it. So yeah, that's quite a big bubbles.
I do have a great video of that, and my favourite thing about that video is you can
these are all the technicians for the dangerous stuff and stuff.
One year we launched the water rocket because I can't remember what we were thinking about at the time. Energy, maybe. It snowed, it was snowing, it was lots of snow in, I think it might have been 2009-ish.
So this is Miss Morgan.
So it was Miss Morgan and
it was a long while ago.
Graham Metcalf, our old physics technician, and basically we decided to launch this water rocket, and it was a beautiful day. It snowed and the sky was pretty clear. In my memory, it's really completely blue sky and no wind. But anyway, there wasn't any wind because when we launched the rocket, eventually, then it goes, it shoots. Oh, what's going on in this video? Anyway, it goes straight up, There's a bit of editing going on there.
So this is all very professional at
Yeah.
the minute.
So this is things that go wrong. So this is me falling over a snowdrift, which is down by the Gelbot Way, as I back up here to try and get it all ready. Yeah, the next thing that happens is that we launch the rocket. And it goes straight up, quite some distance that's gone out of shot. And then that's it, it comes straight down on Graham's head. And yeah, the audio on this is laughing to begin with, before we check that Graham's all right, but he was okay. Yeah, so we do have lots of fun, but it's also a huge amount of work, and I kind of miss sorting it out this year.
Yeah, this year I don't know if you.
Give me a shout when you're going to let it go.